Hi, and welcome to my video on constructing perpendicular bisector of a segment using a ruler, compass only. Ruler and compass only. Number 1, draw a segment AB 6 centimeters long. So I'll lay down my ruler and we draw a segment 6 centimeters long. So I place my ruler here and I'll draw from 2 to 8. 2 to 8 is 6 centimeters. Now another way, without using a ruler, I could also lay my compass on my ruler and stretch the compass out to have, this compass has a radius of 6, so I could put my compass at the end and mark off a 6 like that. I could have my segment longer. Now that I have my segment of 6 centimeters drawn, I'm going to label it A on one end and B on the other end. Now I want to construct B. I want to construct the perpendicular bisector of AB. So I place my compass at B, and I'm with a radius of my compass more than half the length of AB, so that's half. Remember, got to be more, because if we don't have more than half the length, it won't, the arcs I'm going to draw won't intersect. So there's a radius more than half the length of AB. So I will draw the perpendicular bisector by doing two sets of arcs, equal distance from A and B. So I have a circle here. I'm not drawing the whole circle right around, just drawing part of it. And I'll place my compass at A using the same radius, and I have my two arcs drawn. So I'll take my ruler and join where the arcs intersect, join those points up, and I have this segment is the perpendicular bisector of AB, meaning that this is a right angle here, and meaning that if we mark the midpoint of AB as M, so the midpoint of AB, because we bisect it, that means that M, this point here, is the midpoint. So that means that because we have a bisector, that means that MA, if AB is 6, then that means AM and MB should be 3 each. So let's use our ruler and see if we measure. Perfect. That's MA 3, and that's MB 3. So MA is 3, MB is 3. That means because it's a perpendicular bisector, because it bisects, it makes MA equal to MB because it's acting as a bisector. Now, what we're going to do now is do D, mark points H and F on the perpendicular bisector on opposite sides. So I'm going to mark H on the so this is the perpendicular bisector. So I'm going to mark H right there on one side, and I'm going to mark F on the other side. Let's say right here. It don't make any difference how far away from M they are. I'm just picking these 2 points, 2 locations. So here's H and F. And it says measure the length of HA. So HA is this segment right here. If I join them up, so there's HA and there's HB. So there's the segments that I'm measuring. So HA, let's see what HA is roughly. And again, we take a guess to be, let's see, we say 3.3. So HA is 3.3, and let's see what HB is. And again, roughly 3.3. Don't have to be exact, it's just an approximation. As you can see, 3.3. That means that HA is equal to HB because they're both the same distance. Now, what about F? F is here, so let's draw AF as a segment. Let's say there it is. And let's draw BF. And if we measure those segments, what distance will we get? Let's see. That means it's roughly 3.8, 3.9, somewhere around there. Don't have to be exact, 3.8. And what is FB? It should be roughly the same length. So we get 3.8, 3.9. So that means that FA is equal to FB. So notice that M, what am I trying to come up with? M is the midpoint, so this is M is equal distance from A and B. H is on the perpendicular bisector, so HA is equal to HB. F is on the perpendicular bisector, which is this is the perpendicular bisector, F is on it, so FA is equal to FB. So what does it mean? Well, it means that any point, so if I take another point, let's pick another point. So if I pick this point and call it G, that means that AG and BG would be equal. So it means that if I put any point on this perpendicular bisector, may it be way down here, take this point here and join them up, get these segments, it'll be equal. So any point on the perpendicular bisector of a segment is blank from the endpoints. So this point is the same distance, is equal distance. The points are equal distance from the endpoints of the segment. So any point on the perpendicular bisector, this one, will be equal distance. So whatever this point is, this segment will equal this segment. So I just thought I might do that using the perpendicular bisector, because again we will use it in other videos, other properties that we're going to develop. Now another one. Construct a circle O, center O, with a radius of 3. Construct a circle, center O, with a radius of 3. So let's take a ruler, and we have to have a radius of 3. So we put, again, at 0, and we'll mark the radius of my compass is 3. And I put it down. I'm going to construct a circle with a radius of 3. So I put it right here. I can put it here, but I'll go down there. So let's just put it here. Here's a circle that I'm drawing with a radius of 3. So and there's my center right there. Okay, put a dot where the center is. Right there, there's the center. And that center is O. We mark it O. O is the center of the circle. And it has a radius of 3. So that means any point from the center out to here, any point on the circumference, from the radius, from the center to the circumference is 3. So it's 3 here, 3 there, 3 in length. Now it says draw a chord or a segment BD 4 centimeters long. So a chord is a segment whose endpoints lie on the circle. So I have to draw a chord 4 centimeters long. So again, let's put my protractor at 0 and stretch it out to be a 4. So there's 4 long right there, right on, very close. Again, I'm not concerned that it's exact, but it's pretty good. So this compass has 4 centimeters. So I'm going to draw. So if I put it, no matter where if I put it here, like that, and mark it, so that's 4 centimeters from here to here. But let's, oh, I got my paper moved. Let's keep it in vision straight up to us. Let's put it here. Let's see. Now, there it is. I put it here. And let's go back to here and get that other point. Now, that means the distance between, my compass is marking out these 2 arcs make a segment of 4 centimeters long on this circle. So we join that up right here. So I've made a segment 4 centimeters long. Now, I could go from here to here. I could go from here to here. I can go anywhere, but I don't have to be parallel. I don't have to be with this line here. So there's the segment 4 centimeters long. Next, it says construct a perpendicular from O. Construct a perpendicular from O to, oh, I didn't label, let's mark D and F as these 2 points. The chord is DF. It says construct a perpendicular from O, which is the center, to the chord DF, intersecting at M, a perpendicular. So how do I draw a perpendicular to a line from a point on the line? Well, I put my compass at O, and I have to cut the segment twice with an arc like this. Now, if I want, I didn't have to draw this one, but it's best to make sure that you put it at the center and draw this one. Notice that this arc is, I didn't have to do this arc, because this arc right here would have done, because this is F and D are radii. F and D are on the circle, so OD is equal to OF. So I could have used F and D to draw the perpendicular, or I could do the new arcs. It makes no difference which one you do. But since I got the new arcs drawn, let's use those. I have to take a radius greater than half the length of this segment. So I have to take a radius on the compass greater than half the length of this segment here. If I use D and F, then I have to take it greater than half the length of the segment. So we have a greater than half, so I'll put it right here. That's greater than half the length. Okay, so let's mark this one and put it right here, and mark this arc right here. There we are. And that's how I construct a perpendicular to a line from a point not on the line. So take O, and where the arcs intersect. So I have a perpendicular from O. There it is. There's the perpendicular. And this perpendicular to this right here. There it is, perpendicular. So I drew the arc, and I marked off the 2 arcs here, equal distance, joined them up. So it says intersecting at M. So let's call this point where it intersects DF at M. And it says measure the lengths. Measure the length. Okay, so measure the length of this chord. So we have to measure what's happening to the chord DF. So what's the length? Remember, the chord DF is 4, so it should be 2 and 2. So let's see. Pretty close. Pretty close. 2. Right out to the circle. 2. And over here, we got 2. So that means this is 2. And MF is 2. That means if this is 2 and this is 2, that means M is the midpoint. It's the midpoint of FD. These two, MD equals MF, and they're equal. That means M is the midpoint. That means that OM is, we made it a perpendicular. Now we know that it's the midpoint. So OM is the perpendicular bisector. The perpendicular bisector of DF. And what am I trying to show? A segment drawn from the center of a circle perpendicular to a chord. What does it do? It bisects the chord, cuts it into 2 equal pieces. So a segment drawn from the center perpendicular to any chord. This chord is DF, it could be any chord. If you draw a segment from the center perpendicular to a chord, that means that this segment will be the perpendicular bisector of this chord. So you could draw the chord anywhere. Again, another property that we just practice. But all of these will come up again in the unit on circles and arcs and angles, inscribed, etc., etc. And another one we're going to do. Show by construction that the perpendicular bisector of a circle passes through the center of the circle. show by construction. So we have to use a compass, ruler, that the perpendicular bisector of a chord of a circle passes through the center of the circle. So let's draw a circle. Don't make any difference what radius I pick, but I want to pick a reasonable one so it can fit on the page. Here it is. So let's put a dot here. So I'll see where the center is, because once I take my compass away. So let's take this point as the center. So here it is. I'm going to draw a circle. You got it. Trouble is, because I'm limiting my vision of the rotation here, it's easy to drop the you can see easy. So I try not to block what I'm doing. So there's my circle. Here's the center, and it says show that the perpendicular bisector of a chord passes through the center of the circle. So let's draw a chord. Remember, a chord can be drawn anywhere. So I can draw any length of chord. I can draw a chord from here to here. I can draw it from here down to here. I can draw a chord anywhere. So I'm just going to take a chord, a different chord, and take this one and just put it sideways instead of straight up and down or parallel to these lines. Let's go sideways to them. So it makes difference no matter what the chord is or what the length is. So I drew this chord. So I'm going to show that the perpendicular bisector of this chord passes through the center. Okay, let's construct the perpendicular bisector. How do we bisect the chord, become the perpendicular bisector? Well, we take our compass, and there's the chord. The chord is a segment whose endpoints lie on the circle. So let's take this endpoint, stretch it out to be more than half the length. Remember, it has to be more than half, because that's not more than half. If you do the arc here, and do the arc here on the two ends, they won't intersect. So again, repeat, it has to be more than half. So I open it up to be more than half. Now I'll draw the arc. So I could keep going around and make a circle, but I think that might be enough. So we know that the middle is right here, and the perpendicular bisector is going to come up through here at a right angle. So I have the arcs drawn far enough. Here we go. Put it on the other one, and we draw the other arc. Here we go. So there's the two arcs intersecting. And now we'll join up the endpoints of those two arcs are meeting here and here. So I'll draw. So the perpendicular bisector, which is this line or segment here, is passing through the center of the circle. These are properties that we will discuss more on later, but what I'm doing is doing constructions with a compass to show you, how to use the compass to do different properties. Now, number 4, find the center of the circle. Now we know we have a circle, but we have to find the center of the circle. So how do you find the center of the circle? Using a compass and a ruler. Well, notice just then, we drew a chord and we drew the perpendicular bisector, and the perpendicular bisector of any chord goes through the center of the circle. So if we draw one of them, it goes through the center, but we don't know where it is. But if we draw a second one, excuse me, the second one will also pass through the center. So the intersection of those two will give you the point, which is the center. So let's draw a chord. Draw any chord we want. Don't make any difference. Here we go. Let's take this one. Now, let's draw the perpendicular bisector of that chord. So with a radius greater than half the length of the segment. So there's the chord. So I'll put the compass here and stretch it out so it's greater than half the length. And I'll draw an arc. There we go. Let's straighten this. And I'll put it on the other end with the same radius on the compass and draw an arc. Done. And so when I have that done, I'll join them up. So what I know, based on what I did here, is that this segment will pass through the center of the circle. So there, but I don't know where the center is. It's somewhere in here. Excuse me. Now, let's draw another chord. Let's draw this one. Again, I'm not having them parallel to each other because the two lines would overlap. So I have this chord drawn. So now I'm going to draw the perpendicular bisector of that chord. Again, take a radius greater than half. So this radius, half is about here. So I have to take a radius up the compass greater than half. So let's say this is greater than half. Draw an arc. Put it over on the other end of the segment. Draw another arc. So here we go. Join these up. There they are. So this one meets and this one meet. The two of these meet right here. So that's the center of the circle, right there. Find the center, excuse me. So I'm going to say that O is the center. So I'm going to label it O. And to check that, we take our compass, put it at the center, stretch it out to touch the circle. So there it is. Oh, make sure it's touching. Like this, so you can see that if I do that correctly, and that's the center, I should be able to retrace. So it's pretty good. I'm you know, see it's tracing it out. So that's the center of this circle. And how did I find it? I found it by doing two chords and getting their perpendicular bisectors, because any point on the perpendicular bisector passes through the center. So draw two of them, and where the two perpendicular bisectors, this one and this one intersect, and that's the center of the circle. Again, he's illustrating the property that we have coming from the perpendicular bisector of a segment. And if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content is on my YouTube channel called Math Fully Explained. One word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.